Hello, good evening.
Good evening, ma'am.
Good evening.
Good evening.
ನರಿ ಗುಹೆಯ ಒಳಗೆ ಸಿಂಹ ಇರು
Good evening.
Good evening. Good evening, sir.
Good evening, all. Am I audible?
Yes, madam. Yes.
Yes, ma'am.
Okay. Good evening, all. I welcome all the dignitaries and the participants to this ATAL sponsored 6 days online faculty development program on the innovations in smart agriculture, leveraging machine learning, IoT, and security frameworks. This FDP mainly focuses on promoting the research culture with the faculties and the research scholars and the PG students in the domain of smart agriculture, and it mainly focuses on the combining the new technologies like machine learning, IoT, and security frameworks. So with this brief note, I request the HOD of AML department, Dr. Basappa B. Kodada, to welcome all the dignitaries and the participants.
Thank you, ma'am. Raghavendra sir has joined. Prakash Raghavendra sir.
Yes, I'm there. I'm there,
Yeah.
Professor Basappa. Yeah.
Thank you. Thank you, sir. Hello, everyone. Good evening, one and all. It's my great pleasure to welcome you all to this inaugural session of the AICT ATAL sponsored online 6-day faculty development program on innovations in smart agriculture. It's organized by Department of Artificial Intelligence and Machine Learning, Kendra Engineering College, Mangalore. At the outset, on the behalf of Kendra Engineering College, the Department of AML, and the organizing team, I extend a warm welcome to all the dignitaries, resource persons, faculty members, research scholars, industry professionals, and participants joining us today from various parts of India. Kendra Engineering College is a premier autonomous institution established in 2001 as a Millennium Projects of Kendra High School Association with a strong commitment of quality education, innovation, and societal relevance. The Department of AIML Learning continuously strive to promote academic excellence, research culture, industry-aligned learning, of which this FDP is one of the significant outcomes. We sincerely express our gratitude to AICT and ATAL Academy for sponsoring the FDP, for their continuous support in enhancing the faculty competencies and promoting emerging technologies across the nation. I take this opportunity to respectfully welcome our beloved principal and president of this inaugural function, Dr. Nagesh HR, for his constant encouragement and visionary leadership. I welcome you, sir. It's my honor to warmly welcome chief guest of this today's inaugural function, Dr. Prakash Raghavendra, whose presence adds a great value to this inaugural session. I welcome you, sir.
Thank you. Thank you.
Dr. Raghavendra is a senior fellow at AMD based in Bangalore, where he leads the many research projects in advanced computing, applied artificial intelligence, and scientific machine learning. An accomplished technologist and thought leader. He has been invited to deliver many technical talks at prestigious international conferences and actively support an emerging research collaboration between industry and academia. We are honored to have him with us today to share his insights and expertise. We look forward to his insightful address. Once again, I welcome you, sir, to this inaugural function. I extend my heartfelt appreciation and welcome to the FDP coordinator and co-coordinator of this workshop, Dr. Sujatayam, Associate Professor of the Department of AML, and the co-coordinator and Vice Principal of the Canara Engineering College, Professor Damien Antonio Damienlo, for their guidance and efforts and support organizing this FDP. I welcome you, sir and madam. I also warmly welcome all the deans, heads of the department of various sections and departments, senior faculty members, and colleagues who are present with us today in an online platform. I welcome you all. A special welcome to our esteemed resource persons who will be sharing their expertise over the next 6 days, and all the participants whose involvement truly make this FTP meaningful and successful. I welcome you all. Once again, I welcome you all and wish this FDP a great success, hoping it will be an enriching and impactful learning experience for everyone. Thank you, and have a wonderful inaugural session and FDP. Now I request Dr. Prakash Raghavendra to address the gathering audience. Thank you.
Thank you. Thank you, Professor Basappa. Can you hear me clearly?
Yes, sir. Yes, sir.
Okay, thank you. Thank you very much. So as Professor Basappa introduced, my name is Prakash. I work in AMD, a company called AMD, which is a chip company. You may have heard of AMD in terms of our products such as the EPIC server CPUs and GPUs for AI. The flagship MI300 product, which is competitor for NVIDIA. Now, first of all, I would like to thank the management of Canara College, Bangalore, for giving me an opportunity to talk during this inaugural program of this FDP. Specifically, Professor Damien. We were together at NITK several years back, but he still remembers me and invites, so that's a great thing. I'm very happy about that. Coming to this FDP on newer techniques or AI-based techniques for agriculture is very interesting. I mean, actually, when I read this, when I read about this FDP program, I really like because this is a new area in terms of in two things. One is, of course, AI. AI is not really new because AI is taking over the industry for several years now. You may know that AI is one of the fastest growing technology, I think, ever we have seen, ever, right? In terms of the money it is making, in terms of the impact it has, and across all engineering areas. I don't think any other technology has come very close to, even close to AI in terms of the impact it has in the industry. You may know that most of the industries are running towards AI. Either could be because of application of AI, right? Most of the companies use AI to improve the productivity or improve the efficiency of what they're doing. That's almost covers everything, right? It need not be IT, right? It can be anything. For example, soap industry, etc. I think one of the interesting areas is actually agriculture, right? So that's one. The second thing is, of course, the AI has a huge business impact, which is making companies like AMD and Intel make a lot of money because they enable AI in the sense that they have GPUs and CPUs designed for AI, right? The AI processing. One of the important success factor for AI is you should have high compute nodes, high compute resources, of course, with the power efficient, high performance resources. And only then AI can be successful. If you have a processor which is quite slow, you would not be able to run any meaningful AI techniques because it is consumes a lot of flops, a lot of floating point operations. Unless you have a significantly fast machine, you will not be able to apply AI in anywhere, right? So that's another one. So there are two things. One is application of AI, which is sort of impacts all companies. The second one is how do we optimize the AI infrastructure itself, like where the companies like IT companies like AMD, NVIDIA, or Intel, IBM, Dell are trying to solve the problem of how to make it efficient AI processing. Now, coming back to this FDP program, AI application in farming is very interesting. So there are several techniques which I just read, which is a precision farming, a crop and soil health monitoring using AI, automated machinery, predictive analytics, other techniques, which can be used using AI techniques to make sure that we do the agriculture which is very efficient. So that's very interesting. Now, on the FDP programs, I have also attended several FDP programs when I was actually, though I am now in industry, I used to teach in NITK. That's how I know Damien. I have some experience with academics as well. We conducted few such FDPs when I was in NITK. Now, one of the important aspects of such FDPs is, of course, the continuous learning. You keep learning while you are teaching. Second thing is it's a collective learning, right? So you can always read these things yourself. That's always there, right? So you can always go and read a textbook, or you go to the web, ask Chat GPT, etc. You can learn. But the fun and the effectiveness of group learning in a setup like FDP would be it will give you much better perspective because of the collective learning. So you will learn from somebody you may not know from his background or her background, quite different perspectives, right? It's not just your own thinking or what you think. It's also about what others think. Let us say now about 200 people attending. Actually, I'm very excited to see the number, right? Getting more than 100 registered participants itself is a great thing. So you will get to know the perspectives of several other people from different backgrounds, right? Different backgrounds in terms of the cultural background, in terms of the technology background, in terms of the application background, domain expertise. You learn a lot more than what you could do alone, right? Sitting in a room and then just reading some articles. That would be the best thing. So I'm sure you will make best out of this FDP, and then you'll go back to your institutes and make sure that you do the research in these areas, or you will try to help the overall technology grow in these areas, and more than anything else, you will become a better engineer yourself, right? And then more than I think, importantly, you also have to have a fun when you learn, right? So one of the important aspects of this FDP also is fun activity. I hope that you will enjoy this program for 1 week and learn a lot, right? So with that, I would like to hand over back to the management. Again, I wish you all the best, and then make sure that you make best out of this FTP 1 week FTP program. Thank you very much. Back to you.
Yes. Thank you. Thank you so much,
Thank you.
sir, for your insightful information and encouragement and motivational words to all the participants in us. Thank you
Thank
so
you.
much, sir. Now I request the principal of the Kunda Engineering College, Dr. Nagesh HR, to address the all audience. Thank you.
Good evening, everybody. Respected guest of the day, Dr. Prakash Raghavendra, and co-coordinator and vice principal of Kendra Engineering College, Dr. Damon DeMillo, and coordinator of this 6-day FDP, Dr. Sujata, and the HOD of the organizing department, Dr. Basappa K, and deans, HODs, faculty members, and my dear participants. As Prakash Raghavendra has rightly mentioned, this is actually a new area which will be having a widespread applications in all the fields, whatever the field you name. So you can go for using whatever the outcomes of this 6-day FDP. At the outset, I thank AICT for supporting us for organizing this FDP on innovations in smart agriculture, and special thanks to our management of Kendra Engineering College. Special thanks to our Honorary Secretary, Mr. M. Ranganath Bhatt. He is there asked to support us in organizing any of the innovative activities. It may be a workshop, it may be faculty development program, or any other innovative activity. Is there always to support us. And this FTP innovations in smart agriculture, it leverages technologies like artificial intelligence, Internet of Things, drones, and robotics to create a data-driven and automated farming. It will also boost the efficiency, sustainability, and yield, optimizing resource use through, especially through precision monitoring. You can also go for automating the task like planting and harvesting, improving the livestock management. Ultimately, the goal is to address the food security and the labor challenges. And key areas of this FDP include AI-powered analytics for decision making and IoT sensors for real-time field monitoring and autonomous machinery and drone imaging for crop health and smart irrigation systems. And I hope that this 6-day FDP will surely help all the my colleagues as well as all the participants to enjoy the innovations in smart agriculture. Once again, I thank everybody for making your time to attend this 6-day FDP. I hope that you'll enjoy all the 6 days. Thank you.
Thank you so much for your informative address and mentioning that what are the goals of this FDP and what exactly participants are going to take away from this FDP. Thank you so much for addressing this informative motivation and encouragement words. Thank you, sir.
Thank you.
Now I request the coordinator of this FDP to give a vote of thanks for this inaugural function.
Thank you, sir. Respected chief guest of today's inaugural, Dr. Prakash Raghavendra, sir, principal, vice principal, deans, heads of the departments, distinguished resource persons, faculties, and all the participants. It's my privilege to propose the vote of thanks during this inaugural ceremony of ATAL sponsored 6 days online faculty development program, innovations in smart agriculture, leveraging machine learning, IoT, and security framework. This FTP aims in order to highlight the importance of smart agriculture and to promote an interdisciplinary research and innovations using machine learning, IoT, and the security frameworks in the domain of smart agriculture. First and foremost, I express my sincere thanks to AICT for selecting our FTP proposal and supporting and organizing this FTP. I express my sincere gratitude to the chief guest of today's inaugural, Dr. Prakash Raghavendra sir, for gracing this inaugural and for sharing his very valuable thoughts and insights. His presence has truly added great significance and inspiration to this program. I thank our principal and the president of today's inaugural function for his constant guidance, motivation, and support in organizing this FDP under the ATAL initiative. I thank Vice Principal and co-coordinator of this FDP, Dr. Damien Anthony DeMello, for his dedicated efforts, meticulous planning, and effective coordination in organizing this FTP. I also thank head of the department of artificial intelligence and machine learning, Dr. Basappa B. Kodada, for his constant support and encouragement in organization of this FTP. I extend my special thanks to Mr. Stanley D'Souza, Assistant Professor of ISC Department, for his continuous support and valuable contribution towards the successful organization of this program. I acknowledge the support of all the deans, heads of the departments, faculties, and technical staff for their constant support. I thank all the resource persons for accepting our invitation in order to share their expertise during this FTP. Finally, I thank all the participants for registering for this FTP and for their enthusiastic participation in this FTP. We hope this FTP will be insightful, interactive, and also beneficial to all the participants. We request all the participants to take active participation in all the sessions and uh, 80% attendance is mandatory in this ATAL FTP. So I request all the participants to take actively participate in this FTP and make the best utilization of this FTP. Thank you, one and all.
Thank you, Raghavendra sir.
Thank you. Thank you very much.
Thank you. Thank you, sir. Thank you so much, sir.
almost better idea.
We request all the audience to please mute your mic.
So we'll be starting our first session in smart agriculture. The challenges at 6:30
Your voice is
p.m.
breaking.
So I request the participants be in line. And, Good evening, sir.
Okay. Good evening. Shall I start or should I wait?
I'll give an introduction and you can start later.
Starting an introduction, first I wanted to confirm whether
Yeah.
clear to you.
A brief introduction about yourself.
No. What I mean to say that when before starting, I would like to confirm with you: is my voice is audible?
Yes, sir. Yes, sir. You are audible to us.
Okay. Just a minute. I'll share my screen.
Yes, sir.
Can you confirm me? Is it my voice is audible?
Yes, sir, you're
Yes.
audible.
Okay. However, that when the PPT is it visible to all of
Yes, sir, visible.
Yes,
Yes.
yes,
Yes,
it's
sir, it's
visible.
visible.
Okay. So yeah, shall I start?
1 second, sir. Let me give the introduction.
That's okay.
Good evening to all. So it gives me an immense pleasure to introduce today's distinguished resource person, Professor Jaidar CD, who is currently working as a professor in the Department of Information Technology at National Institute of Technology, Karnataka, Surathkal, Mangalore. Professor holds a PhD in Computer Science and Engineering from NIT Trichy. He is a distinguished academician and a researcher whose primary research areas include plant disease detection using deep learning, anomalous power consumption analysis through machine learning, cyber security, and computer networks. He has successfully guided 10 PhD scholars. He has made a significant contribution to the academic and research community by authoring more than 80 Scopus indexed publications. He has actively contributed to several funded projects. We are truly honored to have you, sir, as a resource person for this during this ATAL FTP. So I thank you for accepting our invitation to deliver a session on the topic machine learning for smart agriculture, recent trends and
Okay. Thank you so much for
kindly
brief
take over
introduction
the
about me.
session. Thank you, sir.
Yeah. Thank you so much for giving a brief introduction about me, and thank you so much for giving an opportunity for me to speak about a few of the work which I done in my student PhD work. Before starting that one, just I wanted to confirm my participants. So participants, I request you please confirm me whether my voice is audible. Should I increase the volume? Any one participant, please confirm me my voice is audible or not.
It's audible.
Yes, sir, it's audible.
Okay.
It's
Audible, sir.
audible.
Yeah. What about the PPT? Is it visible?
Audible. Yes, sir, visible.
Yes, sir.
Yes,
PPT
sir,
visible,
it's
sir.
visible. Yeah. Thank you so much for confirmation. Just I'll give a brief introduction about what I'm going to discuss in today's presentation. Whatever that content I prepared for today's discussion, which is a part of my one of my PhD student who graduated a few years back. So he did a work in the area of a plant disease detection. When he was doing the PhD, whatever the result we got it, and that's only I am going to present as of now. And currently, I am working on other plant disease detection work, which currently is going on. That is a tea plant disease detection. I am not going to discuss anything about tea plant disease detection currently, which is a sponsored project. That content I am not going to discuss about it. Only that one the work which we did earlier as part of my PhD student, that work only I will be discussing. In between that one, if you have any doubts, please ask me the doubts. You can interrupt me and I'll be able to clarify to best of my knowledge. So that's what the content. Why do we want? We have started this work a long back. Maybe I think we have started this work in the year of 2018. He joined for a PhD in the year of 2018. That time we started it. Only a few of the work has started in the year of 2018 in the line of a plant disease detection. So now you can see many of the work has been published in a research area or agriculture area in the direction of a plant disease. But when we started, only a few works were there in the line of a plant disease detection. Why do we want plant desert detection concept is? That's what the one core idea. Why we want this plant desert detection? If you do not have any plant desert detection, and if you are not detecting early diseases of a plant, so how it will impact on that one, society? That's what I thought it come on our mind. So as a human, when we have some health issues, immediately we'll go to a doctors and then we'll get an appropriate prescription and we'll take an injection, the medicine, whatever it may be. We wanted to recover it so that we'll not have any kind of further the health issues. If we are having health issues, it will be significantly impact our families. So we don't want our that I mean our problem are impacting on the family side. That is the reason immediately we are going and we are taking an appropriate precautionary measures to stop that one impact on our family. The similar kind will be there in case of a plant disease. If you are not taking a appropriate step when we are identifying the one plant disease, it significantly impact on the society, particularly in the line of that scarcity for that when the grains. So when the scarcity for the grain or the production of the grain is very less, automatically price will be higher. When a price is higher, then only that when the people who are economically good, they will be able to offer it, and the people who are economically weaker, they will not be able to offer. I mean, they will not be able to take the food for their stomach for the times. If you are not taking that one, uh, if you are not identify the plant disease in early stage, again it leads to a significant impact on the society, particularly the food which we need to provide for the human beings. So that is what that was the one thought which came in our mind, saying that yes, we need to how we are taking care of our health conscious. Similarly, we should take care of that when the plant disease in the early stage, so that there will not be any problem for a society in the form of the feeding of the food for the stomach. So this is what an basic idea of this is. Uh, if the production is the very less due to that when the plant disease, it will affect on a society, as I already said. Second one is it will affect on that when the farmer the income. If the farmer is not having the sufficient income, then again it leads to, the impact on his family also. So this is what that one the main reason of that one. So risk of the plant disease. I mean that one, if we are not identifying that one the disease of a plant in the early stage, it causes on the plant crop. I mean the crop, the growth of the crop. So that is what that one the causes for the crop loss. So which significantly threaten that one the farmer income and as well the quality of the crop. So in order to identify this, I mean in order to address this problem, we thought that one there is an automated the system which will be in a position to identify the plant disease. Why we wanted an automated system? Next start is, yeah, we want an automated system in order to identify the plant disease in early stage. Why do we want an automated system? Again, that question is coming. One is that when we need to take care of the first, the problem is we need to identify plant disease in earlier stage, so that the crop growth will be more. So when crop growth is more and sufficient of a grain will be available in a market, when quality of the quantity and the quality of the grains are available, so people will be able to afford it and they will feed a food for the stomach. That's what the first one. Second one is, in order to identify that one early diseases, we want an automated system. Why do we want an automated system? That's what the next question is. Why do we want an automated system? So many reasons are there for automated the system. One is that when number of agriculture scientists selected by that one the state government or that one central government are very limited, and these people are not in a position to go to that one different farm field and provide an prescriptions or that one prescription or identify the disease in an appropriate time. We has to travel from one place to another place, and after reaching to other place only he will be visiting the farmlands, and then identify that one what could be the disease of the plant, and then he has to give the prescription to the farmer, and the farmer has to go back to that market and purchase that one all the fertilizers, pesticide, whatever it may be. So it is a time consuming activity. So it may, scientist is not going in appropriate place, then when the disease may be spreading from a one plant to another plant. So in a quick amount of a time, in a short amount of a time, the disease may be spreading for the entire area of the farm. So this is another problem. So, okay, even if we have a sufficient number of agriculture officers which are ready to go for a different farmlands, what will be the other sequences? Sometimes there will be heavy rain. So because of a heavy rain, so much of the flood will be there. Because of a flood, one person will not be in a position to move from a one place to another place because of a flood and the road congestion and as well as the potholes. And these all that when the day-to-day problems we are facing in today's scenario. So if scientists are not going to visit a farmland in a right time, in an early stage, due to the environmental effect, again it impact on that when the crop growth and as well as the crop yield. So in order to address these all the problem, so we thought that when there is an automated system. What exactly the automated system is that, so without depending upon any of an agriculture scientists or agriculture officers, the farmer must be in a position to identify what could be the disease of the plant. That's what an idea of this. How the farmer in a position to get that one, this is what a disease of a so and so the plant. So if we get only that when the plant the disease information, is it sufficient for a farmer? No, it's not sufficient for a farmer. So the farmer has to get that one complete that one plant disease, as well as that one appropriate the medicine and other the fertilizers for identify the crop. So all this information need to get on a farmer mobile itself. So this is what an idea we started our the work. If you look at this the left side of the diagram, in the left side of the diagram we have a mobile. In the mobile we are taking the picture of the crop or the picture of the plant, and that the captured images.
We request all the participants to please yourself.
I request a participant to please mute your mic. So there may be some kind of a noise. So if you have any doubts, so please you interrupt me at any stage. I'll be able to take up your queries. Uh, I'll be confirming. Is my voice is audible?
Yes, sir. Yes, sir. It's
Yeah.
audible.
Uh, Thanks for your confirmation. I'll continue. Idea of this work, the left side of this diagram is there will be a mobile, that is a farmer the mobile in from a mobile farmer will take the photo of that when the crop the plant leaf, whatever it may be. We have a different technical difficulties of handling this. Later part I will tell you. So idea here is the farmer will go to the farmland and without depending upon any of a scientist, farmer will take the picture of that one, the particular leaf, only one leaf. Otherwise that one enter the crop or the group of the leaves, whatever it may be, he will take from his mobile, and then mobile will process the data. I mean, there will be an app in the mobile, and the app will be processing the data. And after processing the data for the mobile itself, farmer will get in what is that the type of a disease. I mean, whether that one the plant is suffering from a disease. If it is suffering from a disease, what type of a disease, what stage of a disease, and what remedies need to be taken care to address the identify the disease. So all this information will be there. I mean, your farmer will be getting in a mobile. So overall operation need to takes maximum of 5 minutes or maximum of 1 or 2 minutes. So that depends upon that one how our backend will be working. That's a different issue. Ultimately, I can say that farmer should be in a position to get that one the complete details about that one disease, as well as fertilizer prescription, and as well as pesticide details on the mobile, so that farmer can go to the shop and get all that required information, and they can make use of then he can apply for that one the plant. So this is what an idea we started our work. So once again, I'll recap the overall idea here is the two ways, the two problems. So one is that there is a need of an early the stage, the plant disease detection. Second one is an automated the system. Automated system is required to handle that one the different environmental effect, like the continuous rain for 2 or 3 days, or the flood. As a result, the scientist or the officer will not be moved from one place to another place. That is a time consuming, and only a limited number of officers are available in the state and the central. So these limited number of officers are not able to visit a multiple the farmlands. So that is the reason we thought we want let us go for the automated system. Automated system must be in a position to identify the disease, and after identifying the disease, you should provide the details about what is the disease and what other remedy action need to be taken to address the disease. So this is what an overall idea we have started our work. So once we have this problem definition, then we have started to address this problem definition. If you look at this other side of this the image, the plant disease detection. If this is what a plant disease detection, and next, what are the things which are this is what I will be showing. Okay, probably I think. In the other side, these are all the things which are associated with the plant, the disease detection. Okay. Uh, okay. So I'll be speaking a one by one in later part. Okay. Uh, we have started um, our work with a cardamom plant disease detection. And before going for a cardamom plant disease detection, what are the technical the challenges which we need to address when we are dealing with the plant disease detection? So I said that when in the previous slide, I said the farmer is going for a farmland and taking a picture. So this is what a one kind of the picture. So when you take a picture of that when the plant, or when you are taking a picture of that crop, along with that when the plant will give a weed, will get a weed information also. So the weed information is unnecessary for the unnecessary for the model to identify. So what that when the plant diseases, you can look at this is a cadmium plant, and from this cadmium plant will be having a leaf. Along with the leaf, the background information also there. So background information could be a weed, or it could be some other crop also. So if it is some other crop, if it is a weed, this will be treating as a noise. So because of that one, the presence of a noise, the model will not be able to identify that one what exactly uh, the disease of the plant. This is the one technical challenges one of the major technical challenges. So once again, I'll recap it. So when we go to when farmer is going to a farmland, and if a farmer is taking the picture, from that picture, what is the technical issues? One of the major technical issues is along with that when the plant, the leaf, noise also will a part of a picture. Noise could be the weed, or it could be that one other the plant. If because of this noise, automated the system will not be able to accurately detect. So what whether that one plant is suffering from a disease, if it is a disease, what kind of a disease. So this is the one major challenge which we need to address when we are dealing with uh, plant disease detection, that too in terms of real time. If we take the data set, most of the data set are the pre-processed the data set to carry out the research. But in practical scenario, in a real-time scenario, the pre-processed data set is completely different from the real-time images. Real-time images, the challenges in the real-time images is subtracting removing a noise from the captured images. This is a one major challenge. Along with this, along with this, the background subtraction or noise removal from the captured images. So many different technical issues also there. So what are the technical issues which I'm going to discuss in the next slide? Another technical issue is that one, the environmental condition in that one, when we take the photo of the crop in the morning time, the picture quality will be different. If I take that one, a photo in a evening time, picture quality will be different. If we take in a cloudy mode, the picture quality will be different. So it is varying from a time to time. I mean to say that the resolution of the images, sorry, the clarity of the images, which is very which is significantly depends upon that one environmental condition. That one also we need to address when we are dealing with the plant disease detection. So not only addressing that noise removal, along with the noise removal, we need to address that one other technical the challenges. So the technical challenges is one technical challenge is so what time we are taking the picture. So whether we are taking a picture in the afternoon, whether taking a picture in the evening, whether taking that one the picture in that one early morning. So whatever that thing. So if other the technical challenges is that one the camera resolution also, quality of the cameras also. So these are that one the technical the challenges which will be which we need to address. One technical challenges is the quality of the images. Quality of the images mean that so, what kind of the camera we are using to capture the images. So now farmers will not have a good, I mean, high resolution cameras, or that one high ended the cameras are high specification cameras. Farmer normally will be having that one the low resolution and the normal the cameras. When we have that one the mobile with that normal cameras, the quality of the images is very poor. When we have that one the less I mean poor quality of the leaf images, how the model will be able to understand such kind of a cool poor quality images. This is the one the technical major technical challenges. And the second the challenges which I already explained the previous the slide is, so when you are taking the real time images, the noise uh, noise at the background at the weed removal. So these are that one the two things so which we need to address. And approach to data the plant diseases. So what are the ways to handle this plant disease detection is, one is that when the the approach is the visual inspection. Visual inspection means you go to the farmland and then you identify that to identify the disease by visiting that one the farmland and a visual inspection. And person should have that one the sufficient the experience. I mean uh, scientist or agriculture officers who is going to visit the farmland, and he or she should have that one the a good experience on identifying the plant disease. That is what with respect to that one the visual inspection. Second one is the image processing with the different types of an image. So and third one is the computer vision with various image types. So here I wanted to highlight the difference between that image processing and the computer vision. So I'm not taking with respect to that one the plant disease detection. I'll be giving that one the difference between the image processing and the computer vision. The basic the difference between the computer vision and as well the image the processing is, so very fundamental difference between the image processing technique and the computer vision the technique is, in case of an image processing, the input and output both are images. That's what the fundamental requirement of fundamental concept of a image processing. So input is an image for image processing, and output is also an image for image processing. Whereas in a case of a computer vision, it is not like that. So input could be an image or it could be an audio. So sorry, input could be an image or it could be an video, and the output depends upon that one the what we wanted. It could be a classification result, or it could be a regression result, or it could be something else. So that's what the difference between the computer vision and the image processing. Once again, I'll give you the difference between the image processing technique and the computer vision is, in case of the image processing, so input is an image and output is an image. So example for image processing means that when the low resolution image need to be converted to the high resolution image. So input is a low resolution image and the output is a high resolution image. So always it takes an input and produce an output with respect to image processing. So why this image processing technique is coming to picture of a plant disease detection means, so the farmer will be capturing that one the leaf images with the low resolution cameras. So resolution images so may not be appropriate for a deep learning model or that one automated machine to identify that. In that case, the low resolution image need to be converted to high resolution image. So that is an example for image processing. Second one is the clarity of the image is not proper. The clarity of the image is not proper. Again, some kind of a processing need to be done for that image to convert it to that one high quality images. That's what with respect to image processing. In case of a computer vision, we'll be having a some kind of a deep learning model or some kind of a machine learning model, which will take an input and then process the input and produce an output. Output again depends upon our requirement. It could be in classification. So what is the input is? Input is the leaf, our input is a dog, our input you could use. So that is what the main difference between the computer vision and image processing. So we can use either the image processing technique or the computer vision techniques to address that one plant desert detection. But in our the work, we have used that one the computer vision various computer vision techniques to identify so whether the input images uh, uh, healthy images or whether the input images non-healthy images. If it is non-healthy images, what kind of a disease is it? So after identify that is appropriate message will come to farmer mobile about what fertilizer need to be applied for it and what pesticide need to be applied for it. So that's what we did it. Okay, so motivation, as I already said, that when why we wanted to do this automated early detection of a plant disease. One is that one to improve that one the food the security worldwide, and detecting and avoiding that one the disease in a plant is completely essential. I mean, it is very highly essential to identify or detect the disease in the early stage itself. And next, the motivation factor says that was small scale farmers as well as large scale farmers. So investing in more on detecting a plant disease and pesticides, this accumulates economical the loss. And the third one is so we need, I mean, the today's world needs an enhanced and cost-effective plant disease detection method. I mean to say that when automated the plant disease detection, which is a cost-effective and as well as highly accurate one. That's what. So need an effective real-time plant disease detection. So problem with second point is need an effective real-time plant data detection mean that when in a real time itself user of the farmer should be in a position to capture that one that leaf images and the plant images, then get that one information in a real time itself. That's what the meaning of this. Next one is all this a process need to carried out in the early stage of a disease so that crop loss will not be there. In order to withstand the crop loss, there is a need of an early stage of a plant disease. So these are the motivation factors for us to take up our the research work. So how we initially we thought how we initially we identify the problem statement which is need to address it, and later after identifying that one problem statement and we thought how we can address this problem. So initially we had an idea, but later stage we could not implement this idea as an, I mean, exactly same, but more or less we have implemented our idea which is matching to the initial research the plan. So what we thought in the initial the stage is you deploy one the deep learning model in a cloud environment. That is what it says. This is what a cloud environment, and develop an automated system and put it on the cloud environment so that farmers can access that the plant disease detection model round the clock. So this is what an idea of this. And the farmer is going to the farmland and capturing the mobile. So capturing that when the photos in a farmer mobile itself, and that when the app which is running on the mobile will transfer the data to a cloud. That's what we have. That when the bidirectional arrow, bidirectional arrow means that when the mobile app will capture the images, and captured images will be sending to the deep learning model which is deployed in the cloud, and cloud will take the input. I mean, deep learning model which is deployed in the cloud will take an input and process the input and give back the result to a farmer, the mobile. So that's what an idea we thought of. And next one is that when we cannot depend upon only one the model. So when normally when we have some kind of a serious health issues, we'll not go for a one opinion of a doctor. So normally we'll go for a second opinion and third opinion. After taking it when the one second opinion, third opinion, we'll confirm that one yes, doctor, the diagnosis is correct. So based on that one, the second opinion. We'll confirm that we should we go for an operation. This general trend is not always will be followed. The general trend is if any when we go for a doctor, if he says suddenly unexpected health issue, if they reported saying that you have this, suddenly you have to go for an operation, people will not agree and will say that okay, why can't we go for and take a second opinion for a second other doctors, let me confirm whether this is appropriate or not, then we'll go for a second doctor, then will take an opinion of a second doctors, and second doctor opinion and third first doctor opinion if both are same, both are same, then we'll confirm that yes, that let us go for the next level of a treatment. So that's what I usually the trend in our human life. So similarly, if you are developing the only one model, and we cannot depend upon the result is given by only one model. So we thought that one we can go for that one the different model one and model two and then the model three. So DLM1 is a deep learning model one and the deep learning model two and the deep learning model three. So that's what the meaning of it. So we will be having that one the different deep learning model. I mean, all the model will be training with that when the same training instances, but the model name is different. So the training process will be same, but model name will be different, and architecture of the deep learning model also will be different. So once we train that one the deep learning model one and deep learning model 2, which is completely different from the model 1, and the deep learning model 3, which is completely different from other two models. So in this diagram we mentioned that one deep learning model n, it could be a 4, it could be a 5. So we are given a generic either n. So we'll be having so multiple deep learning model, and these model will be training the deploying on the cloud. In order to deploy and run a multiple that train the deep learning model, we want a cloud. That's the purpose of using the cloud. And when we submit any input from a mobile app, it will go to a cloud, and from cloud it will be transferring to a different deep learning model, and each deep learning model will identify so whether given input is healthy or the unhealthy in the disease. And again, this also will say that healthy and as well the unhealthy, it is health or unhealthy, and we'll take in uh, measurement. So here I'm saying that one if the sum of n is greater than 0.5, I mean to say that one will be taking the majority of this. So we'll be adding uh, all this, and then we'll take in average of it, and after that one we'll checking that one whether that average is greater than 0.5. So we are not saying that one is a greater than or equal to 0.5. We are saying that one the point greater than 0.5. I mean to the majority voting will be considering, and based on the majority voting concept, we'll say that one whether that one given input is healthy or not. So this is what initially we had an idea. With this idea, we have started our work, and when we are completing our work, we could not deploy that one our train model on the cloud. Other than that, we have done that one rest of the things, except the deploying trained deep learning model. We have done the rest of the work. So this is what an initial the research area we started in the year of 2018. How this we started our first result is, yeah, uh, how we started our research result is so first of all, I would like to confirm that why we wanted to study, why we want to do the research. Purpose of doing a research is today research is a tomorrow technology. Please be noted that why many places people will ask why we wanted to why you are doing the research. Today research is a tomorrow the technology. In the field of research, we are going to show that when the proof of a concept that is coming in the product form, that is called the technology. In my understanding, it is there in that one in a public domain also. So today research is the tomorrow technology, and during the research we wanted to show that one this concept is works fine. It means we are showing that one the proof of a concept with that with available the resources. So later the same concept will come into the product form, so that the user will be using in a day-to-day activities. So in order to carry out our research work, to convert our research work into a product form, we have started that one the systematic way of collecting the literature. So when the model which we are, I mean, most of the people will follow that one the model that is called as the Prisma model. This is a universally accepted method to collect the literature. So I think many of you may be aware about that one. What is the Prisma model? Just I'll give an idea about what the Prisma model is. The Prisma stands for the preferred reporting items for systematic review under the meta-analysis. The idea of this one is how to collect the literature. So nowadays we can collect that one the complete literature in one day of a time. So before collecting the literature, we should know that one what are the search engine we are using to collect our literature review. So we will be having a different the search engine. One is that's one. Um, So I'm using that one. These are the publishers I'm calling as a search engine. It may not be appropriate to call this publisher as a search engine. Just for the easy understanding, I'm calling this elsewhere as a one publisher, and the ACM is the IEEE Expert, and MDP and Springer and Taylor and Francis, and as well the Indus Science Direct and Taylor and Francis. Like that one, we have to identify that one, which are the publishers. We need to the search for the paper. So once we have identified that one the publishers from where we are searching for appropriate uh, papers, then you need to go for that one some kind of a keywords. So you need to use that one the particular searching keywords. So you go to the Elsevier and the Science Direct and then use the keywords, and then you I download all the papers. And after doing this collecting the paper from one publisher, then you go to that one the second other publisher, use that one the same keywords, and then you collect then all the papers and download the papers. And the same keywords you can use for some other, I mean next publisher, the same thing you do it. And after that, whatever the paper you collected from a different publisher, then you accumulate all those papers, then you store it in one folders.
Guys, add ಅವರು ಯಾವುದೋ ಏನು ಕಾಲ್ ಅಟೆಂಡ್ ಮಾಡಿದ್ರು, ಅದಕ್ಕೆ ರಿಸೀವ್ ಮಾಡಲಿಲ್ಲ. ಅವ್ರದ್ದೇನು
Is mute.
Yes, sir. Yes, sir. They are muted.
Okay, is my voice audible now?
Yes, sir. Audible.
Yes, sir, please. Yeah, thanks for your confirmation. Okay, what about the slide? Is it visible?
Yes, sir. It's visible now.
Yes, sir. Yes, sir.
Yeah. How to collect that one literature is that's what I was saying, that when the Prism model is an universally followed model. So once we collected the paper from different the web publishers, then you have to do that when screening. And the screening is initially initial level of a screening is whatever the paper we downloaded, whether it is an appropriate language or not. So in our case, we have seen that whether the language is a Chinese language, whether it is an uh, Germany language, whether it is the English language. We have screened only that one English language, and after removing that one non-English language downloaded papers, so we got less. I mean some number of paper. Again, we need to screen the papers by reading that one abstract. Then we can screen whether the paper is relevant to my area or not. So in this way, we have the screen the multiple the stages, and after the multiple stages of a screening that one the downloaded or collected paper, finally we land up into 160 number of papers. All this 160 number of papers are inclined to plant disease detection. So in this 160 the papers, we have varieties of plant disease, but we collected 160 papers which are aligned in the line of a plant disease. So in this way, we collected literatures, and then we started to move towards carry out my the experiment. Okay, so after the collecting a literatures, the one is the collecting a literature, and then after that one we have to study all the literatures, and after studying the literatures, we need to identify that one what is the outcome of a literature. So these are the outcome of a literatures we landed up during a 2018 and 19, so early after 2019. So one is that one the outcome of a literature is that one that whatever the model I mean prediction model, so it must be a more accurate. And second one is multi-network model. What is the meaning of a multi-network model is so instead of going for that one the only one network, will be having that one the more the network, that is what called as a multi-network. So the one is that one the multi-network model which should be an accurate. That's what that one we have seen that in the literature we have seen that there's a need of a multi-network model which is an accurate. That's one now. And next one is most of the papers will not speak about the classification time. In neural network in earlier days and even today's also, the amount of a time which we are using to train the model is immaterial. It could be one day, it could be a 10 days, or it could be a 1 month, or it could be a 1 year to train the model. That is not a major requirement, but how quickly your model will give a result, so in the real time environment. So when I'm giving input, so how quickly your model will respond for given inputs, that is the most important kind of a thing. So once again, I'll highlight that on second point, classification time. Classification time means that when the response given by the trained model in a real time is most important, irrespective of the time which we are spending to train the model. Okay, so that is in most of the literature they did not discuss about the training time and the testing time. So that's what we come out as a one outcome of a literature. So even in today's scenarios also, if you look at a paper, they're concentrating only on classification accuracy, respect. I mean, without mentioning that one the training time and testing time. Anyhow, training time is not that much important. At least we need to concentrate for that one. That one the testing time. The testing time is how quickly your model is responding for your input. That's we need to concentrate in today's scenario also. And the next one is that when the automatic the next one is that when your model should be an automated the model. So what is the meaning of an automated model? Means in a real time the data we need to capture it, and without any kind of an human intervention, the captured image should transfer to the remote system, and from remote system the response should come to the mobile. That's what it is called as the automated. So including that one the capturing of a real-time images and transferring the captured real-time images to the trained model, and trained model will process the input image and give us a response back to the former mobile. All these information must be automated with a limited number of a human interaction. That is what it is called as automatic. And the next one is the cost effective. How much time it will take? If your model is, if you are forcing a farmer to take my mobile off with 10,000 rupees or 20,000 rupees, and farmer will never come forward to take such kind of a mobile app. So if you are selling that one mobile app just as a matter of 100 rupees or 200 rupees, then people will say that okay, it's a matter of only just matter to 100 rupees or 200 rupees, let me take that one app, I can use it. So that is the reason we said that one it must be an automated, and it must be a the cost effective, and it should be in a position for a farmer to use that one the mobile app in a real time environment. So that's what automatic and the cost effective real time plant disease detection is very much essential for that one the small scale farmers. So once again I'll recap. The automated mean that one the with a limited number of a human intervention, all that one that captured the image and transferring the image to the deep learning model, and processing of image by the deep learning model, and giving result back to your mobile app. Everything should be automated with a limited number of an human interaction. Next one is a cost effective, means that when if a model is if you are selling a model for a farmer for a 10,000, 20,000 rupees or 1 lakh rupees, and no farmer will come forward to take your mobile app, and we cannot give a free of a cost for a farmers, because we are spending so much of a time to deploy the model, train the model. So some nominal amount should be there. So that is what it's called as a cost effective. And the real time mean that when the farmer must be in a position to capture the image in a real time. And again your model should take care of that one, that one major the technical difficulties. One is that one the clarity of the image and the quality of the images. If that So all this the technical difficulties need to address in your model in the real time environment, and your model should give a quick result for a small scale farmer, whatever the small, whether the large scale, small or small scale. That's what we identify, that this is very much essential. And next one is only the few works have considered that one noisy images. And noisy in the same images in the sense that one the background images. So in the earlier slide I have shown you this. So when we capture the images, the background could be an other plant, or background could be a weed. So we are calling this as the noisy images. Okay, so only a less number of a work has considered that when the noisy images for a plant disease detection in a real time. But that is most important to address that the handling of a noisy images. I mean to say the real time images. Most of the data sets are class imbalanced. So this is very long back, but now the freely available data sets more or less is a balanced data set. But when we started, that time it's a class imbalance. So why the class imbalance means, why it is called class imbalance means the less the disease, the leaf images, the number of disease images are very less. Annotated the disease leaf images are very less. That's what it was the imbalance. And healthy images was more, and less number of images are unhealthy images are the disease images. That's what it is the framed as imbalanced images. And another the technical challenges is the two the diseases uh, that some diseases show a similar disease symptoms. I mean to say that the diseases are different, but symptoms are more or less are the same. So I mean, once again, I'll say that symptoms are more or less same, but diseases are different. So how the model is going to segregate this, identifying this the disease. That's also another the technical challenges which we need to address. But in most of the literature, they did not uh, address this. They did not consider this issues. And next, another one is if I give an input, whether this the input is, I mean, when I'm giving an input to a deep learning model, when the deep learning model need to identify whether the input image is healthy or unhealthy. If it is unhealthy, is it because of an nutrition deficiency? That's another technical, I mean, another the issues we need to address it. Sometimes because of an lack of a fertilizer or the lack of a water or environmental conditions, sometimes that the plant leaves or plant may look like a disease, but it not infected with a disease. That is also need to be identified the deep learning model. So these are the things which we have come out of, which we have identified during outcome of our literature survey. Okay, next, what are the technical the challenges? Yeah, and during our literature survey study, and after completion of a literature survey study, we figured out these are the technical challenges in the line of a plant disease detection. One is a complex background in the sense that when just I said that when the noisy images in the sense the plant, the image consists of a weed or it could be another plant, that is called the complex background. So when your camera is capturing images in real time, your model should segregate the background. I mean, model should subtract the noise images, and we should consider only that when the required the plant, the leaf images or the plant images. So how we have to address this the problem? That is what it is called as the complex background images. And the next one is that one determine the disease life cycle. So in our human life also, when we say cancer, we'll be having the stage 1, under stage 2, under stage 3, under stage 4, and people will say when it reach stage 4, they say that when the final stage. Similarly, we need to identify that one what is that one the stages of a plant, the disease. Is it in the initial stage or is already reached the moderate stage or the final stage? That's what the meaning of the determine the disease life cycle. And the next one is the nature of the diseases, whether it is spreading from a one plant to another plant or is it suffering only on that. That's what it's called the nature of a, and the nature of the image. As I said that when we take in images in the morning, the quality of the images will be different. When we take images in afternoon, quality of the images will be different. When you take in the cloudy environment, quality of the images will be different. When I'm taking the high specification cameras, high resolution cameras, the quality of the image will be different. When I'm taking that low resolution quality of this all comes under the nature of the images. And
So
next one is
some are texting in chat box like screen is not visible.
oh, screen is not visible. So now is it visible?
It's visible, sir. It's visible. For us, it's visible.
Screen is visible, sir.
Participants, just check your network.
Screen is visible, sir. No issues.
Visible, sir. Visible,
Yeah,
sir.
it's visible.
Okay, shall I proceed?
Visible, sir.
Yes, sir.
Okay.
Sir, you
So
can
my
go
voice is
ahead.
audible? Is my voice is audible?
Yes, sir.
audible.
Yes, sir,
Audible.
it's audible.
Yes, sir.
Okay.
Yes, sir.
Audible.
Audible.
Yes, I'll be speaking about the next the challenges segmenting the multiple diseases in a single leaf images. When I'm having that's the concern of the segmentation task. When I'm having one images, how we are going to segment that one multiple parts of the image. That's called segmenting a multiple diseases in a single leaf image. More specifically, I'm having a one leaf image. Anyhow, I'll discuss more about it. If I have a one image, and in that image will be having a different parts, the disease parts, maybe one in that one the corner, one in the top, one in the middle, one in that one the left corner, one in the other corner, like this. So when the disease parts are a different parts, so how to identify that one? Okay, this place there is a disease, this place there is a disease, this place so when we have a skin the infection, sometime this skin infection in our body may not be continuous. Sometimes there will be a one patch in one place, in another part another place, in another parts another place. Similarly in the plant also, so the disease symptom will be different place in the leaf. So we need to segment that. Yeah, this part there is a disease uh, symptoms. This part that comes and segment in the multiple diseases in a single leaf images. And next, image capturing condition, as I said, the morning or afternoon, and the geographical status of the plant. Next one is the climate change and environment. So these all the challenges in a plant disease detection. And those who are working in this area, you can take any one of the challenges and start to address in your research, or you can take the few of the challenges you would start to address it. But in one research area, it's not possible to address all the challenges. So as per my understanding, that one, if you start to address all the challenges, then it may not be an appropriate way of doing the thing. You take only a few limited number of challenges, then you started to work to address that. That's in our the research work. We did not concentrate more on the segmenting of multiple images. We are concentrating only that when the complex background images and the real time images, and next one the classification time and real time. So how quickly our model is giving that one the response, that's we address it. And again, we have addressed this is a multi-class multi-class classification problem. Like that one, in our research work, we have taken only that one the set of that one the challenges, and we address it. All the challenges we did not address in our research work. Okay. Once we have identified this are the challenges at the end of my literature survey, to start our work, so we collected the data set. This is what one kind of a glimpse. Probably I think that when the fonts are not readable, I will tell you the what is this fonts, because the slide is very small. It's not possible to fit into that. In you can refer our paper, you will get an idea about this. What is this uh, the taxonomy is, to start our research work, we want a data set to train the deep learning model. First, we will identify that one whether the data set is publicly available or non-publicly available. That's what we segregated: publicly available, non-publicly available. So when we go for that one publicly available, then we identify that one whether this data set is a binary class or the multi-class. And when we have that one multi-class, what are the different types of planned assets? Similarly, when you come for that one non-publicly available mean they have used the data set for their own research work. They may not be interested to share the data set publicly. Sometimes they will give the data set based on the request. Sometimes they may not give it because of so many restrictions. So we segregated that whether the data set is publicly available, whether the data set non-publicly available. If it's a data set publicly available, we identify that one whether it's an binary class or the multi-class. If you have that one binary class or multi-class, again we have said that one whether it is a balanced data set or imbalanced data set. Same thing, we segregated to non-publicly available data set, and it gives that one complete picture about that one what are the data sets and which are the sources you can get this. So that's what an idea of this slide. Because of the tiny font size, probably I think you'll not be able to read the fonts. Okay. uh, yeah, this is what one publicly available data set. One is the same whatever I said, the publicly available, non-publicly available. I'm segregating this, the publicly available data set, and in this publicly available data set and single plant leaf. It's not a multi-plant the leaves. So these all that one the authors you can get. One is the rice plant, another one is the coffee data set and rice plant. So like that one, these are related to a single plant data set. Next one is publicly available multi-plant data set. Means that when in one data set we'll be having that one images of so multiple plants. That's what the meaning of a multi-plant data set. In one data set will be example in if you take that one plant village data set, probably yeah, you can take this as a plant village data set, and this is one of that one the widely used the data set. It consists of a so many number of a plant images, like we'll be having the grape leaf images, we'll be having an apple leaf images. Like that one, the so many different types of leaf images are available in this plant leaf images, and it's also publicly available images. Next one is we could not take that one the data set which is non-publicly available. I am not sure whether we wrote a email request email to get it or not. I'm not remembering it, but we could not make use of any of that one non-publicly available data set in our research work. We have used publicly available data set, and we have created our own data set to carry out our research work to show that our proposed method is working well for the publicly available data set, that is a benchmark data set, and as well as our own generated the data set. So that's what we did in our research the work. Normally how we will start our research work is first to get a grip on the hands-on experience. The research work has to do that on some kind of an experimental work. So before going to work on the novelty work, researchers should have an hands-on experience on experimental work. So with that, we have started on experimental work. experimental work. This is not a very great work kind of, I think just my student want to get an hands-on experience on the line of a plant asset detection. So that's the reason I told him to take that one, some experimental work. So that is a way to the start the research work. When the first time when a person is coming for a the research work, so you should get a complete grip on the experiments. So then he will be able to think about a novelty of the work. So to make my research scholar to get a grip on experimental work, then I told him to do some kind of an experimental study. So what this experimental is, multi-convolution layer based convolution neural network. What is the meaning of this? Is convolution neural network is a widely used deep learning model. So multi convolution layer convolution neural network will be more than two hidden layer we have used it. That's what that simple concept of this is. Idea here is we have done that one, that whole work is divided into two parts. One is the training part and the testing part. In the training the phase, we are training the train model. Once the model is the train, and the train model we are saving it. For the saved train model, we are supplying the test images, and test images will be supplied to the trained the deep learning model, and deep learning model will give the classification result as the predicted. This is what that one very elementary explanation about my experimental work. So once again I'll recap it. The work is broadly classified into two step. One is the training phase, another one the testing phase. And training phase involves that one training the deep learning model. And once the model is the trained, I mean once we have evaluated the performance of the trained model, once we assure that when the trained model is working well with the training data set, then we need to save the model. So most of the researcher will not save the model. Please be noted that once the model is saved, so the model need to be once the model is trained, and model need to be saved. But most of the papers during the training itself, they'll supply testing data. I think that is not an appropriate way of doing the thing. So why we wanted to say the model is, just you have to imagine that when once how the model will be in the real world, the real-time production environment. So in a production environment, the model is already trained, and the trained model will be deploying the real world application. So in a real time, the data will be supplying for the deployed the deep learning model, and that deployed deep learning model will keeps taking an input, and will give the output. So by mimic that the real time environment scenario, so we say that when that the trained a deep learning model, and for the saved a trained a deep learning model, we are supplying the test images, and it will give a result. Based on this the result, we'll further we'll evaluate the performance of the model. So if the difference between that one, the training performance and the testing performance, if more or less the same with the difference of 0.5, 0.6, zero 0.6, then you can say that your model is performing well for both training and as well as testing. So this is the way we need to carry out the experiments. It's a very elementary the explanation. Next level, okay. So this is what we have done that one, the multi convolution layer based convolution neural network. Idea is very simple. You probably, I think some of you maybe are familiar about the convolution neural network, and those who are not familiar about the convolution neural network, if time permits, I'll explain about a convolution neural network. So in this, we'll be having that one, the multiple hidden layer. That's what we are called the multiple convolution layer. So this purpose of the convolution layer used to capture that one the features that generate the feature map. That's what the prime goal of this the convolution layer. So we have that one the input, and next one is we'll be having an another convolution layer like that one we'll be having, and the bn is the center of the batch normalization, and for every the input image is processed with the kernel. So in our case, we have used that one the 3x3 kernel just for the purpose of uh, processing this. And next one is the bn means batch normalization, and dropout in the sense in this some the neurons will be the inactivate. That's what the meaning of a dropout. And next one is here we are having that one fc means the fully connected layer as a dense layer, and we'll be having a fully connected and a dense layer. So this is what an overall the architecture of this. And next, if you look at this, we'll be using this the 222 cross 222. The meaning of a 222 cross 222 means the input image dimension is that 222 cross 222. That's what the meaning of this is. So in those who are having the, for those who want more details about this, I'll be able to take up the discussion in case if a time permits. After doing this experiment, after doing this experiment, we got some kind of an result. And what we did is we wanted to show that when the model is working well for different types of the plant leaf images. So in order to show that when the model is working, model is working well for the different types of a plant disease, we are take that one. This is the one, the pepper and the strawberry and the peach. So this is the one plant, this is another plant, and this is another plant. So we wanted to show that the model is working well for a different types of the plant. That's what so we conducted, and these all that when the performance matrix are widely used to measure the performance of the trained model, and how long the model need to be trained. So whether the model is performing well for that when the less training, or the model is performing well for the more training. So we wanted to show that when the model is performing well for up to certain after certain epochs, the model is model performance is the stagnant. You can see that when after 150, so the model performance is, it is showing that one 99%. Okay, so that's what we have conducted some experimental result, and it is depicted here. um, okay, next work is uh, ensemble the work. So if anybody having any question up to, otherwise it's a way of taking the class is only one direction. So probably I think it may not be appropriate speak in one direction. So now if you have, I'll give it time for you to ask a question. If you have any question, then I can take up a question for 5 minutes. Now time is 7:30. So after 1 hour, I'll give a chance for you to ask a question. If you have anybody having any question, please. Anybody having any questions? Till so far, whatever I covered.
Participants, please ask your queries.
So I have a question related to the. Hello, am I audible?
Yes, you are audible. I am able to hear your voice, please.
Yeah, like because in the images, what we see is only leaf is shown. Like all the diseases of the particular plant is concerned are related only to the leaf, or even the other diseases are taken care.
uh, uh, I understood your question like this is, so we have used only that one the leaf, right, to identify the disease.
Yeah, yeah,
So we
yeah.
are not use the other parts of the plant. That's what your question is.
Yeah, yeah, that's right.
Okay, so the disease of the plant. See, example, I will tell you when I see the face of a person, I can identify that one whether the person is active, whether the person is suffering from the health issues, right? So by seeing that one the face itself, we can identify. Yeah, today he looks kind of dull, or his if eyes are red, and his tongues are little bit thick. So like that one, some kind of a symptoms of the disease we can identify by seeing the human body, human facial expression itself. Similarly, for the disease of the plant, by seeing that one the plant leaf itself, we can identify that one whether that one the plant is suffering from the diseases or not. The primary source of identifying that one whether that plant is suffering from a disease is by observing that the plant leaf itself. In that way, we are considered only that one the plant leaf, because in case of you, if you go for the rice plant, the rice plant will, by seeing that when the rice plant leaf itself, will be able to identify that one whether it is suffering from the nutrition deficiency, whether it is not suffering from nutrition deficiency, or whether it is water is insufficient, water is a more kind of a thing. So what we got an idea here is to identify that when the plant disease, the leaf is more than sufficient. So based on that only, we stick on our work for analyzing the leaf rather than other parts of the stem parts of the plants. We did not work on the stem parts of the plants.
Yeah, great, sir. Like why I ask this, like there are a few diseases where the primary cause will be from root, and few diseases are from stem. Because if you take example mango, in mango, if there is an insect called stem borer.
No, two things are there. Here we are concerned with that with the leaf, not the plant, the trees. The trees is the different, and the plant is the different. So our work is only for the plant disease, but not on the tree disease. So if we call it a mango tree, will be there. So we'll not call the mango plant. So we are concerned only for the crop. So in that way, so there will not be any the stem for analysis purpose in our work. So our work is fully restricted only for the plants, so not on the tree. Even we did not work on the coconut also. The coconut we'll call it the trees. So in that way, we did not consider for the any stem parts and other parts of the this.
Okay, fine. Thank you.
So any other
I
question?
have a question. I
Yes,
have a
please.
question, sir.
Yes, please.
Sir, with the perspective of cost to benefit analysis, if we are trying to ascertain how effective is this particular model which you're working on, you said you are not trying to work on the level from the image processing, wherein your brother computer vision, if I understand that correctly. Is that so, sir? Can you please confirm?
Yeah, you are. No, I told about that one. The difference between that one computer vision and the image processing. In case of a computer vision, input is an image and output is an image.
No, I understand. So
And a
which
computer,
option are you taking in?
no, we are using that one only the deep learning model, which takes, see, computer vision is it takes image input as an either the image and as the videos. That's the primary basic understanding. Output of that one computer vision is it may be a classification or it may be a regression or is something else. But in our
So which
case,
one?
computer
Yes.
vision only. We are using the computer vision and particularly for deep learning model.
Correct. So if I understand correctly, the farmers who are going to be the end users are going to
True.
be looking at some output in terms of text, or maybe in terms of anything rather than image. Am I right, sir?
The output is first they have to get what the disease is. That's the one thing. If you are getting only the diseaser name, there's no useful for the farmer, right? Again, the farmer need to go to that one the fertilizer shop and have to get it. So instead of
Yes.
the burdening the farmers along with the disease, a farmer also will be getting that one some kind of an pesticide details and some kind of a fertilizer. If a
So
pesticide is
basically
not
some remedies, isn't it? So remedies,
correct,
how to
right,
work on it so that
prescription,
the
it's
problem,
kind of
yeah, the
yeah.
problem what they're facing that could be evaluated. Now, if
So
you come up with the final tangible output device, so what would it be generally costing? I'm not asking for a specific answer, sir. Any amount, whatever works. And
no
what
here
exactly would be the accuracy of that device? Because you said that there's the challenge is collecting too much amount of data set because we don't know whether the picture what is showing on the leaf, is it because of one disease or is it because the symptom may be similar? So how to overcome this particular challenge?
okay, I'll take up your question like this is you want that one what kind of a disease is affordable for the farmer, right? That's what you are
Yes.
answering.
Yeah,
Okay.
what
See,
exactly, how does the system identify, because of the lack of, the challenge is lack of data set, as you said, isn't it? So how do
correct.
we train our model in such a manner that we have holistically every single details about the disease, and it can pinpointly be accurate in identifying what the problem is, what the disease is, and thereby giving the remedies?
Okay. So I'll tell you the first one is that one we have the multiple plants, right? In this universe, we have a multiple plants. First and foremost is you concentrate on only one plant disease, not more than one plant disease. Is it clear? First, you take any kind of a one, maybe a tomato plant, or you can concentrate with the onion plant, you can feather the cadmium plant. So whatever that way, you stick on to only one plant. That's the first and foremost. Second one is that one, if you have that one, the disease, as in today, when we take a particular plant and the set of that one, the disease is already fixed. So we have to concentrate for that one, which the disease is more the majorly impacting. So if you go for that one particular region, one disease may be majorly impacting. If you go for that one different region, the disease may be impacting it. First foremost is you take one plant and then related to that plant, the how many number of diseases are there. You consult with the scientist at that one agriculture office and jordan all the things. After that one, you have to collect the data set, and after collecting the data set, as we are a computer science scientist, we do not have any other knowledge about that one what the disease. We need to approach that one the scientist to label that one the images. So it depends upon that one how many number of an images you are going to train you are going to use to train the model is left to you. And if you have an enormous amount of computing power, you can train the model with a huge number of the resources, I mean your huge number of the images. If you have a less number of the images, then you can show only the proof of a concept, and somebody will be taking up your work to come as a product. I mean to say that when some kind of an agency will come forward to train the model with a bulk number of images, and then they will release the product in the real time environment. So this is the another issue. Next, if we say that when the which is that when the affordable devices means that when the farmer, most of the farmer economically they're weaker. If you're asking a farmers to purchase another equipment to deal this plant effect, they will not come forward. So nowadays all the farmers will be having that one the mobiles, and most of the farmers will be having that a smartphone where they will be in a position to take the cameras. So with this cameras, I mean the camera mobiles, so they should be in a position to make use of the model, deep learning model. Next, when you come for the deep learning model, if a network is not available, not available, and the forward will not be in a position to transfer the data. That's what one of the model which is lightweight model is a mobile net. We have that one, the different versions of a mobile net. Mobile net is mainly purely meant for that one mobile device, so which will be having a less number of parameters compared to other the deep learning model. So you can train your model with that one the bulk number of the images on the mobile net and deploy that one your apps in the mobile, so that your mobile device will be having a only one the plant layer, the plant uh,
As
plant
a
which
subject.
yeah,
Yeah, as a
as a
subject, one
subject,
plant.
only one
Yeah.
plant, and the farmer who is having that app, they will be in a position to use only that one plant. So example, you have that one the farmland of 4 or 5 the crops. In that case, you should have a separate app for a separate crop. You cannot go for that one only one app for the multiple crops. That is impractical also. Technically, it is not possible also. See how we have that one the heart experts, I mean cardiac experts and eye experts, and next one is the gastrology experts. Like that one, we will be having a separate model for a separate plant.
Correct. So, I mean, like, the two, if I can understand, because this topic is quite lengthy, sir, and and this is not like a one-time exercise to get over with. We can't get answers for all the questions for sure. But then over the period of time, the challenge what I see is that the farmers would get to know the disease much better than what the machine is going to tell, because of their experience, because they are cultivating, doing in the same area itself. So I don't think much of the farmers would be, I don't know, willing to take up the technology or not, and that too at a cost. That again is like basically a hunch feeling. I'm not so sure about it. But anyways, a very good initiative, sir. Thank you so much. I have got the answers for my questions.
Okay. So any other questions? Any questions from anybody else? Okay. So no other participant having a questions? Okay. Next, I will go to some technical.
Sir, like,
yes, please.
sir, like, plant disease ಯಾವ ತರ I think do you know Kannada speaking, sir?
Sorry, sir. Sorry, sir, I did not
Uh,
understand.
Kannada speaking, sir. Do you know?
Yeah, I can speak in Kannada also. That's not an issue.
Okay.
No, we did not work any of that one Kannada related text from train model. Everything was in English only. Because of some other reasons, we could not do any of the work in the Kannada language. I mean, in my work, we did not get that one the message in the Kannada text. So we can do it. That's not an issue at all. Converting the English text in the Kannada text, that is a very trivial task. But we did not do that. So all the communication which is just, I'll come back to this 1 minute. Okay, before going far, yeah, you can see this is the classification result and the prescription. Just I'll give an idea. So user will be capturing that one image, and that will be sending to that one image pre-processor, and then it will go for that one the train model, and train model will say the classification result. If it is equal to healthy, message will come to the mobile. If it is a non-healthy, it will go to that one the pesticide prescription model, and the pesticide prescription model will give that one prescription to the user mobile. So whatever the result it came to a mobile device, it was in a English language, not in a Kannada language. So it's not a great task of converting that one English text into the Kannada text, but we could not do that. I hope I answered for your questions. Did I answer for your question? Did I understand your question correctly?
Yes, sir. Yes, sir. The same.
Yeah. Okay. So any other questions? In another half an hour time is there, so that. Okay. in another 20 minutes time I'm having another one important the work. This I'll be skipping. It's an ensemble deep learning model plan disease. We have that. I'll be skipping on this major things. I'll come back to this. Okay, this is what the publication which got a good number of a citation. Why this? Probably I think it's more long back itself is 100 plus citation was there. Now probably I think it might have reached a good number of citation. I have not updated recently. The reason for citation is this work we published in IEEE Access Open Access Journal. So that might be the reason that paper was accessible to many other researchers. So due to that, it might be the one reason that it got more number of a citation. So another the reason for good number of a citation is when we are dealing it, it's the first the work to best of my knowledge it was the first work which was dealing with background images. So in that way, so it got good number of a citation. As in today also, it's not got a good number of a citation. So what is this work we did is this work is purely for the cardamom. As I already answered for the question, so we cannot come up with one deep learning model to handle that one multiple the plant disease. So we should have a separate model for separate plant life. So we have done this the work in for only a cardamom plant leaf disease detection. What the work we have done is we have taken the real-time images. That's what the real-time images, and in the real-time images we will be having the background also. That is what the more crux or the more challenging in this work. So how to the subtract the background noise? Okay, so to subtract the background noise, we have used that one use net, and it's a pre-trained model, and you can surf in that. So what does use square does? I mean, by using that one use net, we are removed that the background. You can see that when the virginal image is real-time image, and the real-time image is having that one the background noise. The background noise, as I said, that one the data which is not required by the deep learning model. That's what we called as the background the noise. And to subtract the background noise, then we have used the use net. After subtracting the background noise, we have got this kind of an image. So this background subtracted image is consist of only that one the leaf images, and this leaf images we are used for the image resizer, because that when the deep learning model needs images of a same size. I mean, whatever the image size which we have used to train the model, the same size. And why this image resizer required is when we take that one the inputs in a real time, depends upon your cameras, the size of the images will be varying. If you take real time images from your camera, the size may be different, and if I take that one real time images from somebody else's camera, the image size will be a different. So when we deal with the different the cameras to take the real time images, the size may not be the same. So size will be different in terms of a pixel. So that sometime you may be getting the 120 cross 20, sometime you may be getting the 120 cross 120, sometime you may be getting the 220 cross 220. So different image size from a different cameras. So whatever the images we are capturing it, if we send it as it is to the trained model will not accept it. So whatever the image size we have used to train the model, the same image size should be there. So in order to make that one our the input should be that one input image should be same as that one image size which was used during a training. So we wanted one image resizer, and after resizing the image we are sending to that one the deep learning model, and deep learning model will be giving the result. So this whole process is completely divided into training phase and the testing phase. And training phase is involved that one the training of the deep learning model, and testing phase is involved that one the testing of the trained deep learning model. So in case of a training phase and the testing phase, and both the time we have used real-time images, that is the noisy images or the background images, and this background images is subtracted. After subtracting the background images, you can see this only that when the background is a black color. So you can need not be a black color, you can keep whatever the color you wanted. If you want, you can background is the white color. If you want the background is some other color, you can keep it. But in our work we have used that one background is the black color. So after this background subtraction, we are supplying for the deep learning model. So this is what our overall the work which we have done it. As I said, when we are doing it, so probably I think our work was the first work which we are dealing with complex background images. That's the reason it got a good number of a citation. Even today also, every week we used to get a citation. Okay, so how this the background subtraction is done? As I said, we are using that one that use square the net, and what the use square net does is, and using this use coordinate, how the background is subtracted. Simple task is the idea here is you take the input image, and then for the input image you generate the mask. Using this the mask, what you do is you keep this mask over this image itself. So once again, I'll say how this background is abstracted is by using the use coordinate, and how this use coordinate useful to remove the background is, so take this input image and generate the mask, and the mask will be having only two colors, that is a black color and white color. And after getting this mask, you place this mask on this image or the original image, and you see that when the what is that when the background color and the white color. So if the white color pixel means you retain that one original pixel of the pixel of the original image. If it's a black color means you keep it the back the black color as it is. So in this way, so we will be in a position to remove the background noise using a use coordinate. One thing I wanted to the highlight, I don't know whether it's appropriate to say this the scientist name, because when we are dealing with the cardamom plant, we were not having that one the complete the disease details about cadmium plant, and we approached one person, one scientist, because now the everything is recorded. I don't know whether appropriate to pronounce his name or not. So we approached this scientist, and this he only help us to label that the disease. So by taking a help from him, and we were in a position to label the captured images, and the whole image dataset is generated by us only. It's not taken from publicly available the net. So we created a real-time the image dataset, and with that created real-time image dataset, we did an experiment that is purely for cardamom plant. So this is a simple example. The first one is that, so you can see that real-time images, and for this real-time images we have generated the mask, and after generating the mask, just by using this mask, we have removed the background. After removing the background, we have resized it. The last column is the all the images having the same size. That is what the resize. Second images also, you can see that this is what real-time images. For this we have generated the mask, and after generating the mask, from the generated mask we have substituted the background there, and the size of this is a different that one required size. That's what we have resized it. Same thing for the another setup. So this is a just we wanted to the show that, so how the original images is, and how the background is subtracted using that one mask. And once background is subtracted, then we are resized it. So this is what that one, okay, so this is what that one that we did it. Okay, okay, the first one is the first the work is uh, this is purely with respect to cadmium plant, and I'll reiterating, it is not this data set is not downloaded from the internet, and this is the data set is generated by us. And how we are generated is, my student he had the farmland near to this some Sakleshpur, something like that. Okay, so he went to his farmland and he captured the photos, and of size this much 174. And in this we'll be having this as a blight, this is a one disease, and next one is the healthy images of 781, and another one is a disease which is having the 366. So these 1724 images we only captured it, and all the images are labeled by scientist whose name is I showed in a previous one. And next one is whether the model is performing well only for our own data set, or whether our model is performing well for other data set also, I mean other plant live. So in order to show that when our model is working very well for the different data set, we have taken that the plant village data set. So in that plant village data set, we have taken only the particular the leaf, that is what it's a grape. Okay, so again, this is not an the tree, this is a plant. The grape is not a tree, is a plant. So we have taken that one the grape, and just in order to show that one our model is working well for both our own generated data set, and as well as that publicly available benchmark data set. In order to show that, we have taken this a grape the leaf from plant village data set, and we have used that CNN and efficient net and efficient net version 2, the efficient net version 2 and the small, efficient net version 2 and the medium, and the efficient net version 2 as the large. So these are the different classifiers we have used in our work to show that the which classifier is performing the well. And these all the result we got it. And our the cadmium plant desert detection accuracy is 91.3%, and efficient net last two is performed well by achieving the accuracy of 98.26. So this is what one experiment we conducted, and we have done. Okay, so this is just is whatever that I'm showing, the same thing is an enlargement of this. Okay, this is just to show that. So we have done that one different type of an experiment. And what this slide is, we have taken that one class wise performance. So what is the class accuracy, and what is the class, just we wanted to show that one, is there any kind of a bias for a particular class or not. From this you can see that one our model is working well for different types of a class. It's not to bias towards any particular class. That's what this result of this. And this is for the cadmium plant, the data set. Again, we wanted to show that is there our model will performing well for different data set. Under this, the class wise, this is one class, this is another class, this is another class, it's all experimental the work. Okay, as I'm reaching to the time, last for so 8 minutes I'm having. So before concluding this, we have done another work with this is with respect to tomato plant leaf disease detection. So what is the difference between this work and other work is, so this is the work which will give only the information that whether the plant leaf is healthy or non-healthy. So it won't give any kind of an fertilizer prescription, the details for that. So in order to extend our work, so we have included one more the model. It is called as a pesticide prescription model. As I already said that the overall idea of this work is related to the plant tomato plant, the disease detection. What is that extra we have done is, so we'll be having that one mobile app. Okay, from the mobile app we'll be capturing that one images, and then we'll be sending that one the train model will be having a will classify the result. If it is equal to healthy, then there will not be any information with respect to prescription of a pesticide or the fertilizer. If a input is classified as a non-healthy or disease, then the information will be passing to that one another model that is called as a pesticide prescription model. And pesticide prescription model we already hard coded for which disease, for this disease what is the appropriate prescription. Accordingly the information will come back to the user mobile. From this user will be the farmer will get the disease information as well as the remedy information also. So this is what we have done. And again this work is limited to a tomato plant disease detection. What is the extra we have done in this work is, so we have done this, there is a concept, it's called the multi-level future fusion. The idea in this case is, so you take the feature at every layer. So instead of depending upon the features derived at the last layer, you take that when the feature which are derived at this layer. Okay, that's what this the feature m1, and the next one is the feature m2 and feature, and all the layers, layer 1 features and the layer 2 feature and the layer 3 feature and as well layer 4 the feature. You fusion all the feature and then use that one all the fused feature for a classification purpose. So that is what it is called as a multi-level the feature fusion network. So I will recap once again before concluding my work. And this is what one work. In this work we have done classification. Along with the classification we have done the sending that one the prescription to the user the device. That's what. Then what extra next is, we have done the concept as a multi-level feature fusion the technique. Normally in case of a deep learning, the feature which are extracted at the last layer will be used for a classification. But in our case what we did is we are extracting that when the feature at the different layers, and all the feature will be fusion, and the fused the feature we are sending for the last layer for a classification. That's what we have done it. And more technical details about this is available here. You can, so your paper also is available in publicly. You can refer our papers and get the details. Okay, next is a generic the information, those who are interested in AI in agriculture. So you can work on these all the different the areas. One is you can work on the weather forecasting, you can work on the precision agriculture, you can work on the crop management, and you can work on the livestock the management and the field condition management. In case of a field condition management and soil health, and as well as the water the management. So under this condition we have we already worked on the area of a soil fertility, that's called the soil health. That's a separate the area of the work. So I have not discussed anything about the soil fertility in today's presentation, but we have a good amount of a work in the line of a soil health, that is a soil fertility. Those who are interested, you can work on the field condition management. Next one is the crop management and monitoring the crop and the disease detection and the weed control. So under this crop management, we have worked in the area of a disease detection, and there's a tremendous scope to work on other the topics and the same crop management. There's a monitor the crop and the weed control and the weed detection. Okay, so that is required for the robot. So if we have a robot in the farmland, automatically it will go farm. The robot will go to the farmland and identify that when the weed, then it will remove the weed from the farmland. That's what an application of the weed control. So we can work on this. And precision agriculture, handling the labor and shortage and agriculture, we did not work on this. And again, we did not work on weather forecasting. We worked only in the crop management and the field of a condition, and the field of a condition, soil health and crop management. Under this we have worked on the disease detection. So tremendous scope is there to work on different topics of each field, otherwise various the topic. So these all the things which we did it. And soil fertilities, okay, this is what the work we have done in the soil fertilities. Yeah. So, that's all from my side. Last 5 minutes, I mean last 3 more minutes time is there for me to take up the question. If anybody having any questions, so please ask the question.
Hello.
Yes, please.
Hello.
Yes.
Yes, sir. I have a question. If you have identified a crop disease, and afterwards, if the disease is there, you have attached attention mechanism.
No, madam, attention mechanism is not for this. There are two things I'll tell you. First one is that when the attention mechanism, everything with respect to the classification results. Okay, classification result, whatever that one, the classification model, in the classification model we have used this all the concept which include that one, the feature of the future, the feature features. Concept is very simple. Thus in case of the feature fusion, we'll be taking that one, the different layer features, and the last layer feature also will be taking, and will be fusing and will be sending for the classification. So this is the complete disease. And after the classification result only, if it is identify the disease, then we are sending that one, the disease information to another module. So that's the attention mechanism concept is lies in the classification model itself. It is not with respect to that one, the prescription the pesticide prescription module. I hope I understood. I answered your question.
Yes, yes, sir. I have another question regarding the same.
Yes,
Suppose I'm developing a system where I have identified the crop disease, and along with that, I have to attach its prediction based on the sequence data, like genetical data. So, is it possible?
no, what exactly that one
Classification and
sequence? No, what is exactly that one, the sequence data? I did not understand, because that one we had the time series data. Okay, in case of a time series data, we are going to that one, that take that one the previous the data, and we are going to forecast the next one. So that is what that one, the time series data. In case of the sequence data, what exactly the sequence data you are going for? If you are dealing with the sequence data, then you have to go with that one, the bidirectional LSTM, otherwise that one RNN, otherwise you can go for a GRUs, not for that classification. So sequence data is what sequence data you are using it, and what that one output you are expected from the sequence data. If you tell me, I will be able to do that. So normally the sequence data will be dealt with the LSTM and the RNN or GRUs, not for the classification model like a CNN and the deep CNN and ResNet and other deep classification models.
sir, suppose if I want to take the sequence data of SNP, genetical data of DNA sequence data of the crop, and based on that, we are predicting any particular feature of crop. Suppose, for example, what will the if we will do the alteration in any particular gene,
Okay,
and
madam,
what
I
will be
got your
the
point. Yeah, I got your point that your classification model you can use it. Yeah, that's not an issue at all. You can use the classification model for that. I got your point. So how people are working on that one? So in our department also people. Okay, I got your point, man. Protein sequence. People are
yes,
working on
sir.
the protein sequence. People are working on the protein sequence. Similarly, you will be having that one, the plant sequence. Yeah, you can do that. Not an issue.
Yeah. Yes, and also, sir, I have a request. If I'm not aware whether the data set is publicly available for Indian people for Indian related protein sequence or any particular the libraries are there, public libraries are there which are of
We
foreign
did not.
country.
we did not work on any kind of a protein sequence and as well as gene sequence with respect to the plants. So we dealt only with respect to the images. If you want that one, you can refer our papers. You can get that one, that complete data sets of image data set only. But we did not work on that one, the gene sequence and the protein sequence with respect to plants. So that's the reason I'll not be able to tell that. So where the data set is available with respect to the sequence data of plants, because we did not work on the
Okay, sir.
sequence data set with respect to plant.
Yes, sir. Thank you, sir. And sir, one more question. There is a boom of generative AI for creating artificial synthetic images of the leaf disease.
Yes, madam, you can do that. What is the problem? You can do that. Instead of that, instead of going for generating the images, better you can go to that one farmlands and one day and spend and you take the images whatever you wanted. Okay, that's the best I will tell you. You will be getting that one the real image rather than the synthetic images. So I won't prefer you to go for generating the images rather than you go to the physical. You go and you capture the images. It won't be a tedious task also. I don't know how the model will be learning accurately if your model is training with the synthetic data. I don't have any idea about it. My suggestion is that one don't go for any kind of a synthetic data. But if you can use that one synthetic data for a testing purpose, but training purpose, I will suggest you to go for the real images rather than synthetic generated images.
Yeah, okay, sir. And is there any setup required for capturing the images for real field data captures?
Yes, madam. Obviously. So you should when I was discussing about that one, it depends upon that one what time you are capturing that images, and I request please the mute your mic. Some people are speaking. Yeah. Okay. So, madam, I will tell you that one. Yes, the environmental condition also is impact a lot when you're capturing that many images. So, what I'm suggesting is that one you take that one the different the condition images. So, one day that one you can take that one the morning images. You can take in afternoon images, and you can take that one evening images, and you take that one the high-ended mobile and the low-ended image, and then you can prepare your own data set to train the model. So that in a real time, why I'm saying this one is your model should be trained with that one the different environmental condition images, because in real time we do not know that one the whether the farmer will be capturing the images in a morning time or afternoon time or evening time. So whatever the time each farmer is capturing is applying to the train model should be in a position to detect it. So in that sense, I will suggest you to take that one the images of different time zone.
Thank you, sir. Thank you so much,
Yeah.
sir.
Yeah, thank you, ma'am. Yeah, any other questions before winding up today's presentation? Any questions?
I think we can wind up, sir. No questions.
Yeah, thank you so much for all of
Thank
you
you very
to.
much, sir.
Thank you, sir.
Yeah, thank you so much for all of you, and I'll be closing my session. Yeah, thank you so much for all of you. Once again, I say thanks. I'll be leaving this meeting. So once again, thank you, and thank you so much, Dr. Sujata M.
Thank you so much, sir, for your wonderful sections and insightful.
Thank you, sir.